Hi everyone. Good morning. Today is Monday, April 24th. And today you have homework 10 and quiz 6 due. So quiz 6 is about session 5.2, 5.3, and 5.4. So in order to prepare for the quiz, I strongly recommend you to finish 5.4, okay, before you take the quiz. And if you haven't finished your homework on 5.5, you can submit your homework 10 on Wednesday if you haven't finished. Is that clear, everybody? But your quiz 6 is about 5.4. You better finish the 5.4 part tonight. Yes. And then our exam is on Friday. So come here earlier, like at 9:50, okay? And then you can start the exam. And then I have a class after this. So if you need more time, you can stay longer. Just add the teaching, and when you finish, you submit your exam. Okay, so time won't be a problem. So, and this is our course website. You go to the very bottom. Okay, this is the. Let me use this. Okay. All right. So this is our course website. At the bottom, you have your practice exam 3 and the solution. Right, everybody? And then this is the review session recording. So this time and the final, we don't have a virtual review session, but this is the recordings. We go over the problems like one by one. And when you watch the recording, you can pause the every step to think through the math. Okay? So first finish it using pencil, and then play the recording and use red pen to check your work carefully, sentence by sentence. Okay? So I show you in the last quiz. Sometimes if you only tell the final answer without showing any work, you lose points. Right? Remember last time if you just say no vertical asymptote or no horizontal asymptote without saying the details why, you lose points. Okay? So please look at the solution word by word, sentence by sentence. Make sure you don't miss something. Okay, everybody? So you can use the solution of the practice exam as a study guide or as like the requirement, how much work you need to show. And yes, so and then if you have questions, okay, after you watch the lecture video, you still have some questions, feel free to come to see me. So when I hand out the attendance sheet, I also give you this paper. You can take a picture of this paper, then you can see my available time. Okay, everybody? All right, so let's continue. So last time we talked about the exponential model, right? We have the formula y equals k times e to the rt. K and r are two constants. The y and the t are variables. We also have like this formula, population equals p of 0 times e to the rt. That is because when we plug in t is 0, we just get k equals to p0. So both of both of these formula are correct. But if your problem were given initial population, then it's better to use the formula on the right. If your problem does not give you initial population, then it's better to use the formula on the left. But they are kind of the same thing. Is that okay, everybody? Mm-hmm. And last time we did example 1, right? We have the two unknown K and R. So usually the problem will give us the information to find those two unknowns. So we were given today there are 10 flies. We plug in Y equals 100 flies, and the T is 2 days. And then we get this equation. And then after 4 days, there are 300 flies. We plug in Y is 300 and t is 4, we get this. And so we have a system of two equations. We want to solve two unknowns. So you want to eliminate one of them. And By compare, we see if we use equation 2 divided by equation 1, the k cancel, right? This is how we eliminate the k. And then because we have the same base, we can combine the exponents, and by the exponent rule, we subtract. Therefore, we get r times 2. And therefore, equation involving exponential expression. You want to isolate the exponential term and then apply ln on both sides. Do you still remember that? And you get ln of 3 over 2. Don't plug in your calculator here. This is the exact number. If you plug in your calculator and then you get a decimal, that's not exact. You only use your calculator at the very last step. So therefore, we get this is the, and then we plug in one of the equations to find the k. So then we plug back into this formula. Okay, we get k is 100 over 3. R is ln of 3 over 2. And then we want to find how many 5s after 5 days. So we plug in t equals to 5. Do you still remember this problem? And then, therefore, we plug in your calculator and you get 520. So we do 100 divided by 3 times e. How do you find the e? You do, look at your calculator, everybody. So you click the second, like shift, and then you click the ln button, right? Do you remember that? And it has the parentheses. And then when you press the ln, it has another parentheses. Make sure you close that parentheses. Otherwise, if you don't put this parentheses, your calculator may think this is ln 3 divided by 2 times 5. Okay, it means the whole thing is inside the ln. So parentheses is very, very important when you type in the calculator. So for those of you who are not in class, make sure you try the calculator. Because I do have students ask me how to use the calculator in exam. In the exam, I cannot answer these questions. I can only answer questions about the questions. Okay. And in your exam, so I will ask you 2 parts. One part is find the population after some days or years. The other part is to find the time such that the population equals to a number. Well, in this case, you set the y equals 2000 and you want to solve for t. Therefore, you isolate this exponential term, right? You divide it by 100 multiplied by 3, and then take ln on both sides, and then you can solve for t. Is that okay, everybody? Yep. So let's continue. Okay, log model. On the Richter scale, the magnitude R of an earthquake of intensity I is given by the formula. So here the formula is given, where I0 equals 1 is the minimum intensity used for comparison. Find the intensity of each earthquake. So here we plug in the numbers, right? So part A, Alaska, R equals to 4. So R is 4. We plug in R is 4. Replace R by 4. And then on the right-hand side, log. If you don't see a base there, then what is the base? 10, yes. I is the intensity. We don't know yet. And we're looking for I, right? And then I0. Oh, this is the old handout. Yeah. And I0. I0 is what? 1. So this is 1. Oh. By the way, anything over 1 is just that thing. Do you agree, everybody? You divided by 1 is just that thing. Okay. So 4 is log I. We isolate the log term. Is it isolated already? No? Yes. Yes. It's by itself, right? On one side. Okay. How do we get rid of the log?
We do 10 log?
Yes. We do 10 to the power on both sides. Is Is that okay, everybody? So when you isolate the exponential term, and then you can look at the base and apply to yes, the exponential function with base 10 here. Okay, so 10 and log cancel. Do you see the I is 10 to the 4th? Yes. So the intensity is 10,000. So this is part A. So far, so good, everybody? Okay, how about part B? Well, your R is 6.3, right? And then your right-hand side. Do you see the right-hand side is the same as this? Yeah. It's log I over 1, I over 1 is I, right? So it's log I. How do we get rid of the log? Base 10 to the 6.3. Okay. So 10 and log cancel. What is 10 to the 6.3? Use your calculator. Give me 2 decimal places. Use your calculator. What's 10 to the 6.3?
It would be 1 million. It would be 1 million point.
Oh, so what is on your calculator? What? 10 to the 6.3? Oh, yeah, it's 0.3. And anyone your calculator? Okay. 199. 262.315. Is that what you get?
Yes, 1.995.
You
Big
have
numbers in my calculator just does the E thing.
Oh, okay. Is that a graphing calculator?
Yes.
Okay, so in the exam, you use scientific calculator. Okay.
Well,
yes.
I'm just thinking if the value is still too large, will it still do the error? Or do that?
Yeah, if it's too large. This one is not. This is still. All right. Okay, so that is the intensity of earthquake. And you can see this problem, the formula is given, and then we just plug in the number and then to find the unknown. Okay, everybody? Any questions about this problem? Okay. All right, other models. Chemistry. Have you taken chemistry classes in high school? Okay, you know the acidity, right? The neutral is 7, right? Okay, so pH equals minus log of, and then so pH is a measure of the hydrogen ion concentrations. Measure a moles of hydrogen per liter of a solution. Find the pH if the number of hydrogen ion is 2.3 times 10 to the negative 5. Okay, and then compare this for solution with pH 5.8. Okay, so this is a formula, right? Okay, this is a formula. Part A, we want to find the pH if the number of hydrogen concentration equals 2.3 times 10 to the negative 5. So you kind of plug in this, okay, hydrogen ion, by the 2.3 times 10 to the negative 5. Is that okay, everybody? Yes, everybody take out your calculator. Plug in your calculator. What do you get? We have a okay. Yeah.
4.63.
Oh, the parentheses is still not here. It's out. It's outside. Yeah, practice also make it different. 4.638. Do you get 4.638? Yes. Do you have a scientific calculator? This is a graph. Yeah, it is. Okay, so yeah. So usually if you see a big screen, that's probably a graphing calculator. Yes. 4.638. Okay, so that is part A. Part B. Part B. Part B. See, we want to compute the hydrogen ion concentration, and we plug in pH is 5.8. So look at this formula. We plug in pH is 5.8. So 5.8 equals negative log of the hydrogen concentration.
Oh, yeah.
Right, everybody? We plug in pH is 5.8. And we want to find the hydrogen concentration. Okay, what do we do? What? Divide by -1. We have log expression. We need to isolate it first. Okay, everybody? So before you apply exponential function, you must isolate the log term. Okay. And here it's not isolated because there is a minus sign right here. Thank you. Okay. Alright, so we need to like both sides multiply by -1 to isolate the log expression. Is that clear, everybody? You must isolate it before you apply the exponential function. Okay. Or if you have exponential expression, you must isolate the exponential term before you apply log on both sides. Is that clear, everybody? Isolate means you only want to see that term by itself. You don't want to see any number multiplied by it. You don't want to see any number adding to it.
Why can't we just do it for A? Oh, wait, never mind.
Yeah, right. Okay, after we isolate it, what do we do? Yeah, base 10. So 10 to the negative 5.8 is 10 log. Now you see 10 and log cancel. Okay, plug in your calculator. What's 10 to the negative 5.8? Because you want to isolate the log. Isolate means you only want to see the log by itself. Oh, multiply both sides by minus. Yeah, multiply by minus. No, yeah, by itself. Yes. So maybe in other problems you have like 3 times log and then you both sides divide by 2. Or if you have yeah, yeah. Right. Yeah. Okay, so what do you get? Point 1, 2, 3, 4, 5, 6. So 1.585 times 10 to the negative 6, right? Yeah, everybody? 1.585 times 10 to the negative 6. How do you get the, are you okay with the scientific notation? You get point one, how many zeros? Is it 5 zeros? Yeah. And then you move the decimal 1, 2, 3, 4, 5, 6. That's why it's 10 to the negative 6. You don't have to. Yeah. Okay, everybody? So this is a scientific notation. Oh, then you get 1.59. So usually keep 3 decimal places. If it's money, then you can keep 2 decimal places because it's cents, but the other number, try to keep like 3 decimal places. Okay, any questions about example 4? So now you know why our course is also a prerequisite for chemistry. Yeah, so you know this, and then you can have solve chemistry problems. Okay, example 5. A cell site is a site where electronic communications equipment is placed in a cellular network for the use of mobile phones. The number Y of cell sites from 1985 through 2011 can be modeled as the following. So here, the formula is given. T represent the years with T equals 5 corresponding to 1985. What does that mean? So T equals to 5 at 1985. T equals to 0 at what? Yes. Right, everybody? You kind of look at the last digits, right? So T equals 0 corresponds to 1980. Okay, part A. Use the model to find the number of cell sites in the year 1998, 2003, 2006. Okay, 1998, it corresponds to T equals what number? Nine, 1980, T is 0. 1998, T is 18. You kind of subtract 1980, you get 18.
Why are we using 1980 and not 85?
Oh,
because this is 5.
So
You-
1T equals 1 year.
Yes.
One T equals 1 year.
Yes. The unit of T is years. T is the number of years after 1980.
Okay.
Okay.
So I have to use it 1998.
Oh, because the problem asked you to find the cell site in 1998, and in 2003, and in 2006. So you find it. Yeah, T is 18 here. Okay. And so your Y, see your Y, you plug in T is 18. So you get 269,573 divided by 1 plus 985 times e to the negative 0.308 times T. What's your T? 18.
Why are we using 1 plus 985?
Oh, that's given from the formula. Yeah, we're given the formula. Y is the number of cell sites. T is the years after 1980. So you don't plug in your T is 98, 98. No, you plug in your T is 18.
So why are these the other values just random?
The other values?
Yeah, why are we using those?
Oh, it's given from the problem. The formula is given.
That's just a formula?
Just the formula. The problem is given as the formula. Like the previous problem. They gave us this formula. We know this formula, then we just use it.
so we don't have to memorize the 2695.
No. You don't. The formula you need to know is the exponential model. Right. This one, yeah. We expect you know.
So you're going to give us the other two problems if we have a problem.
Yeah, if it's not the regular exponential model, the problem should give you the formula.
Okay.
Yes.
Okay.
Right. You don't need to memorize it. Yeah. So we figure out the T, and then we plug in the formula to find the Y. So everybody type in your calculator. Type everything in one line. So 269,573 divided by parentheses 1 plus 985 times E. So put the E. Raised to the negative. You know the button for negative and minus sign and subtraction sign difference?
Yeah.
Yeah, so that is the negative sign. 0.308 times 18. Close parentheses. Close parentheses here means this is the exponent of the e. And then another parentheses, that means your denominator including up to here. So you get two parentheses. Okay, so make sure you know how to type those numbers. Yeah, it was second and ln. That's the e. Where did you get your e?
I use this one again because I never.
No.
The right one.
Oh, this is not e. This is so A, B, C, D, the variables. You have to define what your variables. So your e is that. No? Yeah, your phone. They have some. Did you mean the parentheses? Yeah, insert the parentheses there. Mm-hmm. Oh no, insert. You know the difference between delete and insert? If you need to divide, see you need to divide. Second and insert. That means you can divide. Then you don't need to type the whole thing. 69908.
I got that.
Huh?
Yeah.
Let's see. See? You got different answers. Let's see. Oh, no parentheses here. The parentheses after that. Okay. So, because you need the parentheses here. Because now it's just like divided by 1. It's not divided by the whole thing. And you have parentheses here. Yes. You're welcome.
Super smart calculator, right?
Let's see. Oh, you mean the parentheses. In here.
Oh.
If without the parentheses, it's just divided by 1, not the whole thing. Yes. Okay. Be careful with parentheses. Parentheses is like your baby. So, some of you don't forget this parentheses. Okay? This parentheses means you divided by the whole thing. You're not just divided by 1. Is that clear, everybody? Mm-hmm. So what do you get? 5. And what's the next digit? If the huh? 9. Oh, so the next digit is 9, so you round up. So, it was a 6, right? Then it round up to 7. Right? What do you get? 5. Oh, you want to keep 2 decimal places? Yeah, then you can keep 2 decimal places. So you get 6 point what? 983. Like that? Oh, okay. And then what's the next digit? 0. Okay, then this is good. Yes. Thank you. Is that okay, everybody? Do you get the same answer? Yeah, everybody make sure you know how to calculate. Okay, that is just 1998. Bless you. Next one. See, 2003. 2003 corresponds to T equals what? 23. Yes, very good. So, everybody, you don't need to type the whole thing again. So, do you know that option you can go up to the previous line? You see that arrow? Go up to the previous line. Change the 18 to 23. Yeah, go up and change the 19 to, sorry, 18, yes. Change it to 23. Okay. What do you get? Like that? Thank you.
14, so this is, I got 14, so, oh, I ran it up.
Oh. We have the same number, everybody?
Then you're supposed to round up, right?
Oh, next digits? Oh, like 5, 5, 5, 5. 5, 5. Your next, you mean, what do you mean?
Would you round up
Like
like 3?
3, 1, 4, 7, 6, 4, 4.
Oh, if you want integer, yeah, then you round up. If you want more decimal. Oh, is that what the problem said? Round to integer?
I was just wondering what the problem said.
Oh, okay. All right, so keep going. 2006 corresponds to t equals what? 26. Okay, then your y is just you go up, replace the 23 to 26. What do you get?
202,023. I rounded up. So it's probably not.
Oh, okay, so
It's 203,000.
203,000.
Yeah.
And then?
0 to
Thank you. Oh, if we keep two decimal places, then what do we get?
63.
63. Oh, then that is 2, 2?
22, yeah.
Okay, thank you. All right, so this is part A, right? We figure out the time, and then we plug in the formula. Any questions about part A? Are we all good? Yes? Okay, part B. So part B, we have the number of size, which 250,000, and we want to find the years. So y equals 250,000. We want to find the time. Is that okay, everybody? So now we're plugging y is 250,000. So y is 250,000. And then the right hand side, 269,573 divided by 1.985 e to the negative 0.308 t. Is that okay, everybody? We plug in y is that number, and then the right hand side remains the same. We want to find the t. You see, this is a equation involving exponential expression. What we should do is isolate the exponential expression. Right, everybody? What do we do? There are so many different ways to solve this. Okay, so what do? We don't want the denominator, right? So both sides multiply by that denominator. Do you agree, everybody? By the way you say isolate, you mean it's on the numerator by itself, right? You don't want it to be in the denominator. So both sides multiply by 1 plus 985 e to the negative 308 times 250,000 equals 269,573. Is that okay, everybody? You multiply the denominator on both sides, so then that's why you got these multiplied by that, and the right hand side they cancel, so we only get the numerator. Is that okay, everybody? You multiply the denominator on both sides.
So we want to go from plus 95 to the both sides of the
Yes.
Okay.
Yes. Oh. Yes. Now we want to divide it by this. Is that okay, everybody? No, okay. All right, but are you okay? We get to this step. We want to isolate the exponential term, but it's in the denominator. That's why we want to clear the denominator. So we multiply this on both sides to get rid of the denominator, right? And now we want to solve for the exponential term. We want to isolate this. So you want to get rid of the 1, you want to get rid of the 985, you want to get rid of the 250,000. But what do you do first? Divide it. Right? Because it's this whole thing multiplied by that. So we first divide by this on both sides. Is that okay? Yeah, because you want to get rid of this, right? So we divided by 250,000. So divided by 250,000. So you get 1 plus 985 e to the negative 0.308t equals question? What do you mean?
Because you're gonna have to get rid of the 1 plus 985.
Yes.
You add that together and divide it all.
Oh, we do it slowly, step by step. So here we divide it first, and then you subtract 1 on both sides.
And then
Yes, and then we divide by 985. Yes, let's do it slowly. Let's do 1 operations each time. Okay, so here, don't use your calculator. Just leave it like that. Oh, because if you divide it, your number will get a decimal. So you want to use your calculator at the very last step. Then your answer will be more accurate. Okay, if you plug in here and then you put a decimal, then your answer won't be so accurate compared to when you use your calculator at the very last step. Okay, so keep it for now. And what do we do? Subtract 1. So we get 985 e to the negative 0.308t equals 269573 over 250000. Subtract 1. Is that okay, everybody? Yeah. Hold it. Don't put in your calculator yet. Just leave it like that. Because when you plug in calculator here, you get decimals. Yeah. Do it at the very last step. Then your answer will be more accurate. Okay, now what do we do? Divided by 985. Right? So the left hand side, you get e to the negative 0.308t equals 269573 over 250000 minus 1 divided by 985. Yeah. Do you see the exponential term is isolated? So what do we do? Apply ln on both sides, right? Okay, when you apply ln, you get ln of e to the negative 308t is ln of 269573 over 250000 minus 1. Don't do that. Leave it like that. Because you want to use your calculator at the last step. Your answer will be more accurate. If you do it here and you get decimals, your answer won't be as accurate as you calculate in the last step. Yes. You can do that, but your answer just won't be so accurate. So maybe if you want your answer to be more accurate, maybe you can like put more digits down, then you can still do it. But on the left hand side, e and ln cancel, right? Everybody? So we get negative 0.308t equals The right hand side. What's your T? What's your T? Yeah, law of that. Yes, law of that. Divided by what? Negative. Yes. Oh, I missed a zero there. Oh yeah, it's negative. So negative 0.308. Right. So this is the last step. You see your T is set. So now you can use your calculator. So use your calculator as the last step, then your answer is more accurate. So have everything in your calculator. Be careful with the parentheses. And this is the right hand side, and you divide it by negative 0.308. So you do L and put a parenthesis there first. Oh, I'm missing a zero. Oh yes, I missed a zero. Thank you. Yes, I missed a zero there. And when you plug in your calculator, make sure you have this parentheses. So you put LN, and then you do this parentheses because this is your whole numerator. 269,573 divided by 250000 minus 1, and then parentheses divided by 985. Parentheses divided by negative 0.308. So everybody, you put in your calculator. I want to make sure you know how to do it. It's minus 1 over. See the over 9 contained inside is still inside the log. This is over negative. Here, you need another parenthesis. This is your numerator. If you have this ln of this, we divided by divided by 985, and then all over negative. This is what it is. It's ln of this whole thing. Yeah. What did you get?
I got 30.6493.
Okay. So you get ln.
I got 30.6492.
So you see this is inside the ln. And then you want to divide by that.
Okay, there we go. We got it. Yep.
Divided by negative
You only have to go by
30.64.
30.64.
And then you need another parenthesis. You get 2, 6, 9.
Did you get it?
I don't have a calculator.
3
I don't have a calculator.
25000. Minus 1.
Yeah, you can get a scientific calculator out.
Divided by
I have my calculator, I just don't have it.
985. Another parenthesis that is then divided by negative. Oh, here. 0.308. Do you get that? Okay, 30, did you get 30.64?
Yep.
Okay, let's see.
Yeah, no.
Oh, too many parentheses. Yes. Can you go up there? Okay, so you don't need this parentheses.
Out of here.
Right, this is just when you divide, it's already this number. So, and then,
Can't do this no more.
okay, you need one parentheses here to close with this. Okay. Alright. So you want to don't put too many parentheses, okay? And you also need the necessary number of parentheses. So on your calculator, you put ln, and then it gives you one parentheses, right? And then you put another parentheses. That's the numerator. So 269,573 divided by 25000. Then minus 1, parentheses. This parentheses take care of this, right? And then you divide it by 985, another parentheses. This parentheses take care of that. And then divided by negative, this is negative non-subtraction sign, 0.308. Okay, so those are the necessary parentheses you need. Don't put too many, but don't put too less. Make sure each pair is matched. Okay. Any questions about this problem? Your exam will have one problem about exponential model, and not this long. Okay, now, yeah. So if you see a harder problem, now on the exam, when you see easier problem, you won't be so scared. Okay. Review your formula sheet for exam 3. Okay. So do you remember the first 5 is the one we already know? What's the new one? E to the x. What are the key points? The key point is 0, 1. Okay. So where is my pen? Okay. 0, 1 is here. Okay. It passed through. This is the key point, and it goes up like that. And everybody look at me. You also need what? Horizontal asymptote. Y equal to 0. So write it down on your formula sheets. And then ln of x, it passed through the key point what? 1, 0. And it goes up like that. Yeah, you have vertical asymptote x equal to 0. Okay, everybody? Order of transformation, same as last time. Okay, domain. This is same as last time. When you see ln of a, what do you need for a? Yeah, we need greater than 0. Very good. And it's not only ln, it's actually true with all the log. So you can have log b of a, then you need a to be greater than 0. Product property. So log p times q is log p plus log q. Right? And this is true with all the base. Okay, so I don't put the base there. It's true with all the base. Quotient property, what? P over q is log p minus log q. Power property, log, let be a to the m. What do you do with the m? You will put it in front, log ba. Yes, everybody? And change base formula. You can use any new base. Let's say you use ln. Then you put the a on top, you put the b at the bottom. Sure. Oh, by the way, I will post this on the website. Yes. And we're not done yet. Sorry, one more. Okay, rational functions. First step, you need to factor the numerator and denominator. Second, you want to find the x-intercept, where you set the numerator equal to 0, and the y-intercept, where you plug in f of 0. And then you find the vertical asymptote, where you set the denominator equal to 0. Also, you need to let x goes to that number from 11, right? And you need to determine whether your y goes to infinity or minus infinity. And then you find the horizontal asymptote, where you look at the leading terms of the numerator and denominator, right? And you let your x go to infinity or minus infinity and find the y. And then graph. Also, the formula, what is A? The amount, okay, amount in the account. P is principal. R is annual interest rate. Okay, annual interest. Compound, do you remember that formula, compound interest rates? Yeah, N is number of compoundings. T is the number in years. Right. And this is the formula. Yes.
Have a good week. Have a good day.
Thank you. You too. All right. Yeah, please watch the review session recording.
So I was so